Our city is one of the most polluted cities in Latin America, even having the worst air quality in our country. Therefore, it's easy to infer that our residents are breathing worrying amounts of harmful compounds for their health, which can lead to respiratory, gastrointestinal, dermatological problems.
Some of the most common pollutants in our city's air are carbon dioxide, nitrogen dioxide, dust particles, greenhouse gases, and polycyclic aromatic hydrocarbons, PAHs. These are organic compounds formed by more than two linked benzene rings produced from incomplete combustion of hydrocarbons. When released into the environment, they are dispersed in groups, making their degradation more complex.
Due to the lack of attention given to these pollutants, our project involves designing a biological system for detecting and degrading these compounds using the Escherichia coli bacterium. Initially, we plan to use a natural system sensitive to PHSs from the microorganism Plasticus, adapted through the genetic engineering to produce a red fluorescent protein only in the presence of these compounds. Additionally, it will be able to produce a group of catabolic enzymes capable of degrading HS2UANL, making our project a highly effective biosensor and biofilter for polycyclic aromatic hydrocarbons.
To make this possible, we first had to identify the HAP contaminants present in the metropolitan zone of Monterrey.
This is where our first meeting happened. To help us understand the real impact of the problem and the relevance of the proposed project, Ismael Alvarez, inspector from the Environmental Department from Nuevo León, provided insights on what laws and regulations we should consider. Thanks to him, we knew what application was the best, and we realized the direct connection to escape tubes from industry was not an option. So from there on, the application changed to interiors and more specifically places with a lot of exposure. Fernando Montreal also helped us with sharing information about laws related to dealing with genetically modified organisms, and he mentioned the institutions that support and regulate these laws here in Mexico. The information was consulted in order to know about the regulations and what we have to follow throughout the process of elaboration in our system, things that we should consider in the future for our finished product.
And then select catabolic enzymes that will allow us to degrade them. Next, we obtain nucleotide sequences for their production from publicly available databases, which were then optimized for use in E. coli. Cloning and gene regulation elements were identified and added to make our system functional.
Subsequently, a biological system was designed for HAP detection in the environment based on natural systems sensitive to these compounds in cycloclasticus microorganisms. An estimation of effectiveness of the proposed system was made using mathematical models. Finally, to make our project functional biosensor and biofilter, a prototype was designed to contain the bacteria and expose them to contaminated gases.
As a result, we identified PAH contaminants in the metropolitan zone of Monterrey from various bibliography sources, determining which ones were most prevalent in the area and had the greatest impact on air quality. Additionally, we identified the high health risk possessed by these compounds to the residents, with compounds like fluorine, phenytoin, pyrene, anthracene, benzo-A-anthracene, benzo-A-pyrene being of particular concern. These are part of the list of 17 PAHs suggested by the Agency for Toxic Substances and Disease Registry, and they were included in the review due to the more available information about them, suspected greater harm to health, higher probability of exposure, and higher concentration in the environment. To get a better insight about polycyclic aromatic hydrocarbons, Alicia Ramirez offered feedback to our team regarding these compounds, emphasizing the need to consider factors such as density, chemical composition, rings present in each chemical compound, and their structures, to comprehend completely the processes that the contaminants will go throughout when being degraded in our system. Considering this, we identify catabolic enzymes capable of degrading them, locating 8 different enzymes belonging to hydrolase, hydrogenase, and oxygenase groups. The pre-selected enzymes had the ability to degrade a wide variety of PAHs in the metropolitan zone of Monterrey.
Once the bacterial origin of the selected catabolic enzymes was confirmed from the aforementioned database, their amino acid sequences were obtained from the UniProt database of the EBI. Subsequently, the reverse translation tool from XPASI was used to obtain nucleotide sequences, which were then optimized using IDT's codon optimization tool for recombinant production in E. coli. Cloning elements for the sequences were selected as the ECOR1 and PST1 restriction sites for their future integration into the synthetic biology plasmid PSB1C3 obtained from the Igem Foundation, allowing it to be introduced into our bacteria.
The gene expression regulation system in the selected bacteria consists of the band CC promoted, represented by the transcription factor band R. This system is activated in the presence of vanillinic acid in the culture medium, allowing the regulation of enzyme production and preventing the metabolic overload in the bacteria. The proposed degradation system was assembled in the benchling tool, where it can be seen in the presence of vanillic acid inducer. Our bacteria will produce the proposed catabolic enzymes for PAHS degradation. Here, you can observe the gene code structure we plan to use to turn our biological system into a biofilter for PAHS.
On the other hand, the proposed detection system, also assembled in the benchling tool, involved integrating the coding region of the red fluorescent protein RFP into the PAH sensitive system of Cycloclasticus, allowing its production only in the presence of these gases. This way, it would be possible to detect them only when they were present in the culture medium, turning our system into a biosensor.
Then an estimation of the production and enzymatic activity of the proposed system was performed, along with a mathematical model to deduce its effectiveness in degrading PAHs in the environment. The Spider software with the Python programming language was used for this, involving a series of calculations using differential equations. Initially, the amount of vanillic acid that will enter E. coli was calculated to be 1 times 10 to the power 4 M3. Based on this result, the transcription rate of the mRNA in the bacteria was estimated at 21.2522, allowing the calculation of its translation rate at 1912.884.
Using these values, the concentration of each enzyme produced by a single bacterium was back calculated, resulting in the data present. Subsequently, the enzymatic activity of these enzymes per liter for culture in 1 day was estimated, including the degradation of representative gases for each of the catabolic enzymes used.
A last estimation was made to calculate the effectiveness of our system if we wanted to reach the maximum allowed amount of PAHs as determined by the NOM 025 SSA1 1993, just mentioned in the Mexican National Standard, for phenanthren, benzoypyrene, and pyrene. It was determined that in 24 hours, 40 liters of our bacteria would be needed to decontaminate a 50 meters square space, corresponding to an average room. Finally, a device was designed to contain our biological system and expose it to contaminated air. For this, a cylinder made of 3 acrylic pieces was assembled, with 2 trays having 4 asymmetric holes in the center, an upper lid with an exit hole, and a lower lid connected to an air pump.
To make this design possible, the engineer Adrián Guajardo provided us feedback about the prototype and our biofilter container, in which he gave us information on how an air filter should correctly work. He also gave us an idea for the design of our prototype, as well as he offered critical opinions on how the bacteria could operate mechanically inside the prototype. In entrepreneurship matter, we designed the idea generation, and then we took in account the market research, where we compared our product to other biofilters and biosensors. We realized there's no real competition for this space in the market. Then we defined our vision and the mission that we had, and also the legal structure that we had to follow. Then we prepared a business plan taking into account the market analysis, the market and sales strategies, the products and services description, and the management team. Then we thought about funding and who could give the capital. We passed then to the product development that we had previously done, where we developed the design of our biofilter and the container for our bacteria. Throughout the development of the project and design, it was important to us to understand how much of an impact this will make. In human practices, the people that gave us feedback told us that in fact the project was relevant and had utility. Overall, the opinions were good, and that gave us the approbation to keep going. Besides all of the investigation and designs we made for our prototype and biofilter and biosensor, the team also had concerns about safety. Because of our concerns about safety, we contacted Silverio Alejandro Melchor Rangel. He helped us understand the real importance of safety in the laboratory and also in the design of GMAOs. He told us and teach us what was needed in a risk assessment for its future development.
For example, the elaboration for a risk assessment was done to examine the possible risk we might have with the microorganism and laboratory activities. We also had the opportunity to participate in a biosafety and laboratory correct precautions meeting with the person in charge of the laboratories in the investigation and bilingual education center seated. From UANL with her, we saw the most important things to take in account while in the laboratory.
Even though not everyone around us were scientists or engineers, we had a lot of people helping us in various aspects of this interdisciplinary process. For example, in the recording of the promotional video, Silvia Geraldine Colunga Botello helped us recording and driving to characteristic places of our cities. Also, we had the help of our high school to make different collaboration with teams around the world. For example, a collaboration with the team of Senegal, where we planted a tree in the National Environment Day. To communicate with others about what we were working on, we opened diverse social media as Instagram, X, and YouTube, where we share facts and science communication posts. For this same purpose, we proposed a science week to the principal, which he approved, and throughout the week we had the opportunity to attend meetings and help in the workshops given by professionals. During the Science Week, we had the opportunity to offer different conferences and workshops. One of them talked about the study of science in general and was conducted by Eber Miguel Torres Cordero. He talked about the importance of studying science here in Mexico, where we know that we don't produce a lot of scientists per year. We also had a workshop with him that was about biomolecular techniques. This was completely free to students from our high school. We also had different other conferences that talked about physics, and that one was conducted by Yamile Anais Pez Torres. Also, we had a talk about careers in STEM experience. This was conducted by Raúl Acosta Murillo, Eric Torres, and Cintia Castillo, which were students from the high school. They motivate the students to study something related to science and talked about their experience in these careers. Some other workshops were the elaboration of bioplastics, identification and methods for collection of insects, and also I talked about the secrets of elements and the periodic table. To make everyone feel welcome in this class of workshops and conferences, we also had one talking about women in science. This was pretty special because it was conducted by Marta Liliana Morales Leal, and she talked about how difficult it was being a woman in science and how depreciated women have been. Apart from all the conferences and workshops given, we also had the opportunity to give expositions, one of them being the mathematics stand given by the COMEMAP. We also had a partnership with the Igem HS2UANL team, where they gave an exposition about synthetic biology. This particular activity was fun to students because it gave them the opportunity to learn about something they didn't know exists and play while they were doing it. Every time they play, they win a candy and they learn new stuff about synthetic biology. During the last day of the scientific week, we also had the opportunity to talk about our team and the project that we had been developing around the whole year. The students were amazed by it and they were having a lot of positive opinions about the team. We invited people to know about synthetic biology. To conclude with, we can say we designed and developed a device that will allow the containment of the modified bacteria to do the operation of the proposed biological systems, to act as a biofilter and biosensor for polycyclic aromatic hydrocarbons. This in a full-scale environment taking into account the physiochemical characteristic of such. Throughout the whole development of our project, we learn how to work as a team and also about ourselves. Synthetic biology and Igem in general is a great opportunity to everyone willing to learn.